welcome to this workshop on creating data art with p5.js. During this short workshop, it's going to be about 90 minutes, maybe like an hour, 40 minutes, something like that, plus hopefully some questions at the end. You're going to learn how to go beyond bar, line, and pie charts and create your own custom visuals with code. So this is a coding workshop, so you are going to need a little bit of prerequisite knowledge, nothing crazy. As long as you know what a function is, what a loop is, what a variable is, you're going to be absolutely fine. We're going to be coding in Javascript, but if you're more familiar with Python or R or something else, then don't worry, you should be able to follow along just fine. And if you have no coding experience at all, then that's okay. You can still watch and enjoy, and hopefully you'll also get something out of it. So here's how today's going to run. First, I'm going to introduce you to the p5.js creative coding library for JavaScript. Then we're all going to recreate a famous piece of data art together, writing code in the p5.js web editor. And then we'll look at some of the other creative possibilities offered by the p5 library. And then finally, we'll end with a little bit of discussion about where to get inspiration for data art. Okay? And then finally, a quick note that today I'm going to be teaching you how to make data art, not how to make beautiful data art. Obviously, beauty is in the eye of the beholder, but also I found that the process of making beautiful data art requires the creation of an awful lot of ugly data art along the way. So hopefully by the end of today's workshop, you will have the tools, some of the tools that you need to start making ugly data art, and then it's up to you to decide what you think is beautiful from there. Okay, so thank you so much to Piero for the intro. It was really kind. I'll repeat just a little bit of it because I put it in my slide deck anyway. I'm an information designer and generative artist. I focus mostly on climate and environmental issues, as well as some other political bits and pieces that Piero spoke about. I'm British, as you can probably hear from the accent, but I live in Gothenburg on the west coast of Sweden. I know like one other person in this city who does data visualization, so it's hardly a visualization hub or anything like that, but it is a very lovely place to live, and it's been wonderful over the past year having so many great online conferences that I've been able to attend from the comfort of my own home. I consult for lots of different clients. In the past, I've worked for Wired and Information is Beautiful. I've also done projects over the last few years with the BBC, with Project Drawdown, with the Gates Foundation, and I'm not a pro coder. I'm far from a pro coder, which should probably, hopefully, give you some confidence, I guess, that you can make good things, good like data art pieces without being a pro coder either. If you are a pro coder, then I apologize in advance for all the terrible code that you're going to see today. You can see some of my work at duncangeere.com. I also write a regular blog and a newsletter. And you can also follow me at Geere. And if you're interested in unconventional information design, then as again we mentioned just before the call, you might also want to check out the data sonification podcast that I'm making with my collaborator, Miriam Quick, who spoke earlier today. You can check that out at loudnumbers.net, and that also has its own Twitter account and various other bits and pieces. So follow everything is probably my advice to you. Okay, that's all the plugging out of the way. So let's get started. Today we're going to be working with p5.js, which is a JavaScript version of a Java language called processing that was developed and released in, I think, like 2001, about 20 years ago. There are versions of processing for Python and Android and the Raspberry Pi, and I think various other platforms as well. But today we're going to be using the JavaScript flavor of it, which is called p5.js. You'll want to go to p5.js.org in your browser. I'm going to throw this link in the chat for easy clicking. Where are we? There we go. You're going to need to be here because we're going to be going to the editor in just a second. But before we do that, I'll just talk quickly about why I chose P5 to do the workshop in today. I chose it because it has a focus on making coding accessible and inclusive for artists, designers, educators, beginners, and anyone else. It has a really, really nice set of functions that make coding simple. It sort of takes a lot of the hard work out of coding in a lot of cases, and it also has fantastic documentation under reference that is written in really simple, plain English that even complete beginners will be able to understand at least some of. So yeah, today we're going to be coding in the p5.js web editor. And this is great because it means you're not going to need to download or install anything. All you need to do is click the link that I put in the chat to p5js.org and then hit editor on the left-hand side, okay? So if you click that, that should take you to a page that looks a little bit like this. And this is where we're going to be spending most of our time today. So I'll explain very quickly what is going on here. On the left-hand side here, you have where it says sketch.js. This is the code that we're going to be writing. Everything that we're writing is going to go into here. Below that, we have a console where you can log messages to. It's useful in debugging. I'll talk about that a little bit later. And then on the right-hand side, this preview window is where the sketch, the thing that we're going to be drawing, is going to appear. To run your code, all you have to do is hit the play button at the top. And you can see it's made us a nice gray square, which is beautiful. That's because it is creating a canvas and then setting a background color of 220. Again, I'll talk about this in a minute. Yeah, so the one thing that I should say before we begin is that if you want to save your sketches and come back to them later, I highly recommend hitting the sign up button in the top right-hand corner and signing up for an account, because then you'll be able to save your work and access it at a later date. You'll have a whole library of sketches that then you can access. When you're logged in, you can access through the file open command there, and there you can get access to the other ones. Don't worry about the fact that mine is just on dark. That's because I prefer to be in night mode, because I'm a creature of the night or something like that. Yes, so hopefully some of you have created accounts. I'll give you a moment to do that if you haven't, while I have a little sip of tea. And I'll talk briefly a little bit about the artwork that we're going to be replicating today. So, click through some slides. Here we go. You are probably familiar with this. This is a piece of data art called Warming Stripes that was created by a climate scientist called Ed Hawkins from the University of Reading's Meteorology Department. And through one of the university's grand coincidences, I actually studied at the Meteorology Department at Reading University myself for my bachelor's degree. We did, I think Ed and I actually overlapped for a year or two at Reading, but I've never actually met him. We've just exchanged a few emails. Now, I haven't actually explained this graphic to you, but you probably already understand what's going on, right? You don't actually need to have this graphic explained to you. Time goes from left to right, and the temperature goes from blue is cold to red is hot. And as I think Sandra Rentgen discussed at her talk yesterday, this is because these are visualization conventions that are used far beyond the visualization community, right? Time going from left to right, humans in the Western world write from left to right. And then, yeah, color going from blue to cold, red to hot, that's on all of the taps in the world. So these are things that people will recognize immediately. In this case, the graphic starts in 1850, I believe, on the left-hand side, and it goes all the way through to 2018 on the right. And yeah, the color of each bar represents the average temperature of the Earth in that year. White is average, blue is colder than average, and red is hotter than average. And you can immediately see climate change happening in this graphic, right? Now, this graphic has become enormously popular. It's used by the United Nations Convention on Climate Change. This is a booth at one of their conferences that they did once, as well as a little fluffy bird. I got this picture off from Wikipedia. I don't know why there's a bird in it. Here is it being used in the center here. This is the logo for the United States House Select Committee on Climate Change, right? So here's the Senate, I guess, and here is the warming stripes in the background. And then on the right-hand side, this is the cover of The Economist magazine. Magazines don't tend to put data visualizations on their cover very often, even when they are, even when they're economics magazines. One thing that I find quite interesting is that they felt the need to add an axis to this. I don't think it necessarily needs an axis, but it's interesting. And I think an interesting question to ask before we get started here is, why is this graphic so popular? And I think to understand that, we can compare it to a visualization of roughly the same information, okay? So here is a visualization of pretty much the same data. I grabbed this from Wikipedia. And this is an adequate data viz, right? This shows pretty much the same information that's in the other one. It arguably shows a bit more information because we have this smoothed average in the middle. You can actually see where the data goes from and to, and what the numbers actually mean on the left-hand side. But can you imagine a band projecting this graphic behind them at a music festival? This was Enter Shikari at the Reading Festival in, I think, 2018. Someone may correct me on that in the chat. Or can you imagine a chart being like appearing on the corner flags at a football match? This is Mainz in Germany, or on the hoardings around the stadium. Like, this is pretty unusual. Can you imagine like seeing a chart on a face mask? I actually have one of these myself, which I wear proudly to remind people that the pandemic is not the only crisis we're facing at the moment. And can you imagine people cosplaying as a chart? I've never seen anyone cosplaying as a chart before. This is really interesting to me. And this is the power of data art, right? It can become iconic in a way that most charts just can't. You could definitely make an argument that there have been some charts, particularly this year, that have become iconic, the flatten the curve one, for example, but it's very unusual to see. And one more note on this graphic that I want to say before we continue is that obviously normally it would be pretty bad form to run a workshop teaching people how to copy somebody else's art. In this case, the reason why it's okay to do so is that Ed has given his warming stripes graphic a Creative Commons attribution license, which means that you're free to do absolutely anything you want with this graphic, as long as you give credit to Ed and you link back to showyourstripes.info, which is a website where you can create your own version of the warming stripes for anywhere on the planet. But you're not going to need to do that because I'm going to teach you how to make it from code today. All right. So let's go back to this graphic and let's break it down into its visual components, okay? And this isn't going to take very long because it's a pretty simple graphic. We have a collection of bars that stretch from the very bottom of the canvas all the way to the very top. And we have one bar for each year in the data set. And the color of each bar is encoded to the data. And that's pretty much it, right? It's a pretty simple graphic. So let's have a think about how we might go about coding this. And let's write some comments in our web editor to guide us along the way. So at the bottom, I'm going to put a couple of extra things down here. I'm also going to make the console a bit smaller so that we can see that. And I am going to, write some things in here. So in JavaScript, if you want to write a comment, you can just do 2 forward slashes, and then the computer will just ignore it, pretend that it doesn't exist. It's for humans to read, not computers to read. So obviously, the first thing we're going to want to do is load in some data. So I'm going to write load the data here. We don't have the data yet, but we'll get that together in a minute. Then we're going to want to figure out what the height and the width of each bar is going to be, right? Because that's going to be the same for all of the bars all the way along. So let's write figure out the height and width of each bar. Then we're going to want to figure out the position of each bar, but that's going to be different for each bar. So what we're going to need to do is we're going to need to loop over the entire data set. And we want to say something like, for each point in the data set, we're going to want to calculate the position and the color. So how might we write that? Let's just say something like loop over the data set. And then below that, and I'm going to indent this with a tab to show that this is inside the loop, we're going to figure out the position of the bar. And we're going to figure out the color of the bar. And then finally, we need to not forget to draw the bar. Okay, so this is going to be pretty much the rough structure of what we're going to try and accomplish today. We're going to load in our data, figure out the height and the width of each bar, and we're going to do that programmatically. We're going to loop over the data set, and then for each data point in turn, each year, we're going to figure out the position of the bar, figure out what color the bar should be from the data set, and then draw the bar onto our canvas. Okay? Now, we're going to do this in a few steps, and I'll do some short 5-minute breaks in between so that you can catch up if you get a little bit behind. Depending on the device that you're watching this on, it might be a little bit tricky to see what I'm typing large enough to follow along. You can try putting the video stream and your code side by side if you want to, but it's more important to follow what I'm doing than to copy everything down exactly. I believe there'll be a recording of this available afterwards. And also, when we take breaks, I will share my in-progress code with you in the chat so that you can access it and troubleshoot, catch up, do whatever you need to. Okay, so I think the first thing we need to do then is get some data. Now, we're going to get the data from NASA, and I will give you this link into the chat. And what we want to do here is, this is their Goddard Institute for Space Studies, and this is their surface temperature analysis. And it goes back all the way to 1880, which is, quite a long time ago. You can scroll down here past the updates to the data set, past the contacts and the citation, and the background and the methodology, which is very important to read, but we're not going to do it today. And I want you to scroll down to where it says tables of global and hemispheric monthly means and zonal annual means. And it's these zonal annual means that are what we want. I'll explain very quickly what zonal annual means are. Zonal refers to zones of latitude, right? We're going to be plotting data from the entire globe, but our data set, as you'll see in a moment, has data from just the Arctic or just the Northern Hemisphere or just the area between the equator and 24 degrees latitude south. There are all of these like zones of latitude, and it has figures for each one of those zones so that you can see how climate change is affecting the world in different ways, okay? What we want down here is the zonal annual means. Oh yeah, I should explain the other two. Annual is obviously yearly data. All of these others are monthly data and some seasonal ones. And means are the average temperature of that whole zone throughout that year. So that's the average of a lot of data, okay? And this is 1880 to the present, updated through the most recent complete year. And I want you to grab the CSV file here. We're going to right-click it, and we're going to save link as. And I'm just going to put it in my downloads folder, okay? And then I'm going to open up my downloads folder. And I'm going to right-click, and I'm going to open this with basically the simplest text editor that I have on my system, which is Notepad. And I'm going to zoom in, because this is tiny. I recommend opening it in Notepad rather than Excel. Don't open it in Excel or Google Sheets or anything like that. You want it in text format for this. So use Notepad if you're on Windows, or if you're on Mac, then use TextEdit, or if you have a code editor that you like to use, then you can use that. But get it in text form. And then let's have a look at this information. So you can see that we've got a row here at the top that is the column headers, okay? So we've got the year, we've got glob, which is global data. This is the one that we're going to want. We've also got Northern Hemisphere, Southern Hemisphere, and then all of these other little zones of latitude that I was talking about before, separated by commas. And then below that, we have each year, all of the figures for each one. And you'll notice that these are quite small numbers. For example, this is minus 0.16. And it's important to note in this data set that these are what meteorologists call anomalies, which means they are the difference between the average temperature in that place for that year and a reference period, okay? And in our case, the reference period is it listed here? Yes, deviations from the 1951 to 1980 means. So this is how warm or cold the Earth in that zone is compared to the period, the average for the period 1951 to 1980, all right? And you can see actually, if we go back to this, here is this average period here where it goes above and below the mean, where the mean is set to white. Right, so where were we? We were in the text file. So if you want to know what these numbers actually are, then I happen to know that the average for that period is about 14 degrees Celsius or 57 degrees Fahrenheit. These are all Celsius figures, and we're going to be using Celsius today. I apologize, dudes. And what I want you to do is I want you to select all of the text in this file by going Edit, Select All, and then Edit Copy, or Control-A, Control-C, if you prefer to do it like that. And then we're going to go back to the web editor. Okay. And here's the first little tip that I'm going to give you about the p5.js web editor, which is that there's this little arrow here. And if you click this, you can actually see all the files that are part of your sketch. This isn't shown by default. So we've got sketch.js, which is the file that we're going to be working in today. We've also got an index.html file, which links to the p5 library and pulls in the sketch file. We've got a style document that you can play around with if you want to, but we're not going to be touching the HTML file or the CSS file today in the workshop. We're just going to be working in sketch.js and a new file that we're going to be creating, okay? To create a new file here, you want to hit this downward arrow next to sketch files and do create file, not upload file, create file. And I'm going to call it data.csv. You can call it whatever you want, but if you want to follow along, then call it data.csv. And then hit add file. And then if I click into it, you can see that it's completely empty. All right. And what I'm going to do is I'm going to hit Control V or Command V or whatever it is on your platform and paste in our data. And you'll notice that at the bottom here, there is an extra line at the end of the file. I'm just going to delete that with a backspace so that we don't get problems with that later. But otherwise, you can see that the data goes all the way down to 2019. And from the start, it starts in 1880. And we have this header row at the top. If yours looks like this, then everything is good. Okay, so now let's just quickly explain how to save our work. Assuming that you're logged in, you can hit Control or Command S on your keyboard, or you can go File, Save. And this is the point where you might notice that here you have a different name for your sketch. This one is called Believe Discovery. I have no idea what yours is called because it's random. Sometimes they're quite fun. I'm just going to change this and I'm going to write Warming Stripes. Okay, and then it will resave it under this new name. And if you want to access it later, you can go into File, Open, and get back to it. Okay, this saves the entire sketch, by the way. So you're not just saving the data CSV file, you're saving the HTML file, the JS file, and the CSS file all in one. So let's go back to sketch.js and let's quickly talk a little bit about how P5 works. Okay, so click sketch.js in the left-hand column if you haven't already. In this file, you can see that we have two functions. It says function setup and function draw. Now, P5 has what's called a draw loop, and that means that it's coded so that it will run everything that's inside the setup function. And by inside, I mean between these curly brackets. It's going to run this once, and then this over and over again, 60 times a second, I think it is by default, until you shut your browser or the universe ends, whichever one comes first. And we could use this to animate things, right? By setting up some sort of loop and then, I don't know, adding one to the position every time the draw function runs. And then you'd see like a square moving across the canvas. But in this case, we're making a static image. It's not going to move. We don't need to animate it. And so there's no need to have this draw function looping over and over again. So what we're going to do to stop it from looping is inside the setup function, below the line create canvas, we're going to type in no in lowercase and then a capital L and then OOP and then two brackets like that and then a semicolon. And this basically, this no loop function, this tells P5 that we don't want to loop the draw function. We just want to run it once. Okay. So right now we can look at what we're doing. In the setup function, we are creating a canvas that's 400 by 400 pixels in size, 400 across and 400 down. We're turning off the looping functionality, and then we're setting the background of our canvas to be 220, which is, if I run this, this is going to be a light gray. If I hit this to 0, that would be a black. And if I made it 255, which is the maximum, then it would be pure white, okay? You can give it, I don't know, some crazy number, and I think it will still go, yeah, just pure white. It'll clip it down to 255 as the maximum. But 220 is the default background color, so we can just leave that as it is for the time being. Now, the first thing on our list to do is to load the data, right? So let's bring that up to the top here. Paste it in here. And let's talk about this loading the data process for a second. So there's something that you should be aware of here, which is that our data file, the one that we're loading in, is pretty small, but most data files are not that small. And because JavaScript likes to start new things before it finishes doing old things, sometimes it means that the data hasn't finished loading by the time that you want to work with it, okay? This can be a bit of a pain to get around. You have to do promises and things like that in normal JavaScript, but in P5, it's really nice and easy. You can just create a preload function. So what we're going to do is we're going to copy our setup function. I'm pressing Control-C to copy, and then Control-V up here to paste. And we're going to change setup to preload, all in lowercase. Okay, and we can just get rid of everything that's inside these curly brackets here, but make sure you've still got the brackets. All right, so anything that's written inside the preload function will finish before any of your other code starts. And that makes it a great place to pull in data or load an image or do any kind of pre-processing that you want to do. Anything that the rest of your code depends on should probably go in a preload function so that you can be sure that it will finish before everything else starts. Okay? Now, loading the data in JavaScript can be a bit annoying, but again, P5 makes it very, very easy for us. We're going to use a function called load table. And to understand how to use it, we're going to go into the documentation. So we're going to hit help at the top here, and then we're going to go to reference and click that. And in a new tab, we'll get the reference things open. And there's a nice big search box at the top here. If you scroll down, then you'll see all of the functions and things that are available to you when you're using P5. But we're just going to search for the load table function. And it should say load table method in P5. I want you to click that. And then on this page, you get a series of examples that are nicely commented. You get a description of what it does. This one reads the contents of a file or URL, and it creates a P5 table object with its values. That's exactly what we want to do here. Okay. We also have some instructions about the syntax and the parameters and the returns and all of this stuff, but we don't need to worry about that. Let's just grab one of the things from the examples that looks good and just paste that into our code and then change it to what we want it to be. Okay, so they've got a preload function here, and it says my table is comma separated values, and it has a header specifying the column labels. That's exactly what we have. So that's probably something that we want. I'm going to copy all of this whole line of text. You can do it depending on your platform again with a double click if you want, and copy that, and then go back to my web editor, and inside the preload function, I'm going to paste that with Control-V. Okay. I'm also going to reduce the size of my canvas just a little bit so that I can see it. We've got it 400 pixels across, sounds good, but let's make it, I don't know, 250 pixels tall if I run that. Oh, this is because mammals.csv doesn't exist. Okay, we'll fix that just a second. If we change assets mammals.csv to just data.csv, then this will run just fine. And I'll explain that in just a second. So yeah, now we have a canvas on the right-hand side here that is more in the aspect ratio that we want to get for the final piece, okay? So yeah, back to the load table function. You can see that this has three things after it, separated by commas, and these things after it are called arguments. The first one is data.csv, which you have probably guessed is the data file that we're trying to access. The second one is CSV. This tells P5 that our data is comma separated values. You could also write SSV if you had semicolon separated values, or TSV if you had tab separated values, but we have CSV, so we can leave it as it is. And then this last bit here, the word header in quote marks, this tells P5 that our data has a header row, okay? It has a row of columns, a row of column headers at the top that should be treated differently from the rest of the data, right? You take it away and deal with it separately, okay? So in sketch.js, we've got, we're running this load table function, we're loading our data file, it's a CSV, it has a header, and we are storing it in a variable called table, okay? We're saying table equals this loaded table. And at the bottom, you can see in the console, it's giving us a little bit of feedback. It's saying our separator is a comma, which is handy to know, but I'm gonna make this smaller so that you can actually see everything better. Right, where are we? So yes, we have successfully loaded our data and stored it in table. At least we think we have. What we can do is we can check that this has loaded properly by trying to get a value out of it, all right? So inside the setup function, in between these two curly brackets here, after no loop, on a new line, I want you to write console.log, and then inside it, you can just write your name or something like that. And then make sure it has quote marks around it, and then hit play. And in the console here, you'll see your name appear. This console log command logs things to the console, and this is super useful when your program isn't working and you have no idea why, and you want to find out what's going on. You log stuff to the console, and you get a little glimpse into the inner workings of this black box that you're creating. But in this case, we don't want to log our names. We want to log some data from the table. So what we can do is we can use the table get method, all right? So we say table, because that's the variable that we stored it in up here. And then we say dot get, and then we put a pair of brackets. Make sure that you've got two brackets here and one and left brackets here and here. And we're going to give this two numbers, and those are the row and the column of the data that we want to access, okay? So if we go back into our data file, in fact, I'm going to bring it up in the notepad because it's a bit easier to see. If I go all the way to the top, and let's say we want to get the Northern Hemisphere figure for, I don't know, 1885, let's say. So we say, right, which row do we want? We want 1, 2, 3, 4, 5, 6, 7. And then we want 1 to the third column. So we can write 7, 3 in this. And if we run that, we get minus 0.29. Is that right? Minus 0.2, no, we should get minus 0.43. What's going on? There are two things that are going on here, okay? One is that we told it that we have a header row, so that shouldn't get counted as a row number, all right? So instead of row 7, maybe we should have row 6. Is that gonna fix it? No, now we've got minus 0.20, which is 1 off in each direction. And the reason we're 1 off is because, and this is really important to remember, I forget it all the time, computers start counting at 0, not 1. So this is the 0th row, then the 1st, 2nd, 3rd, 4th, 5th. And same here, 0, 1, 2. So actually we want 5, 2 here, okay? If we hit play, then we get our minus 0.43 value. All right, so we have successfully accessed a data point from our file that we've downloaded, and we've logged it to the console to check that it is working. So let's take a quick break here because we've covered quite a lot of ground to make sure that everything is working nicely on your end. I want you to make sure that this console log command is working and that you're getting your minus 0.43 out here. If it isn't working, then you can check the console for error messages. P5 has very nice error messages generally, so it'll probably give you a pointer towards what you're doing wrong. Be sure, yeah, so I think the key things that I often forget or get wrong are to close like my brackets when I open them. Make sure that you've got the right amount of brackets everywhere. Make sure that your capitalization is correct. JavaScript is case sensitive. So with load table, for example, this T should be capitalized. Yeah, if everything is working, then you can help others in the chat get theirs to work. I will share my code. If you want to share your code with somebody else, you can hit File and Share. And then there's various different ways you can share it. I'm going to share the edit version. I'm going to copy that and paste it in the chat. And yeah, if you're happy with all of this, then either help other people in the chat for the next 5 minutes or so, or play around with getting different variables out, different values out of the data table. See if you can log out the value for the Southern Hemisphere in 1885, for example. That should be minus 0.24. But yeah, otherwise we will start again. It's in my time zone, it's 14:38. So we'll start at 43 minutes past the hour and we'll come back then. All right, I will see you then. All right, I think we're about ready to start up again. I saw a few people having a little bit of difficulty in the chat. Again, I'm going to share my code exactly. So this version is working. We get the -0.43 being logged out. So if you open up the version that I just put in the chat, if yours isn't working, and either code from that from now on, or just copy all of my code and replace your code with that, then you should be able to continue from where we are. Okay. Also, there'll be a recording of this available afterwards, so you should be able to follow it up in your own time if you want to do it that way. Okay, so let's do a quick recap. We have introduced the p5.js creative coding library and its web editor, and we've explained how the setup and the draw functions work, and we have explained the preload function up at the top here, which loads, or it finishes its work, let's say, before everything else in the code runs. We've identified a visual that we want to recreate, which is Ed Hawkins' warming stripes. And we have shown you how to use the documentation, the reference thing, by typing interesting things in here, like rectangle or something like that. And yeah, we grabbed the data from NASA and we loaded it into our coding environment inside our preload function. And then we logged out one of the values to check that it's all working. Okay, so now it's time to start drawing things. Making a rectangle on a P5 canvas is really easy. Inside your draw function, on a new line, you can just type rect, and then we give it 4 things. We give it an X coordinate, a Y coordinate, a width, and a height, okay? And you'll notice that the width and the height here have gone pink, and there's a good reason for that. It is because P5 creates some variables itself that you can use to, I don't know, do things in your visualization. They're kind of baked into your sketch, okay? And in this case, width refers to the width of the canvas, 400, and height refers to the height of the canvas, 250. So we actually need to call these something else. We need to call them something like bar width and bar height. Otherwise, it will get confused as to which is which, okay? The going pink is a really handy I don't know, signifier that you are overwriting one of the default variables in P5, and you don't want to do that if you can avoid it. So we're going to say bar width and bar height. So now, where do we want to draw our rectangle? Let's say, let's draw it 10 pixels off the left edge and 10 pixels off the top edge with a bar width of, I don't know, let's say 100 pixels and a bar height of another 100 pixels. And some of you, especially if you are a pro JavaScript coder, will be wondering why I'm not initializing these variables with var or const or let. And the reason is that we don't actually need to in the P5 web editor. It works just fine without it. And it's a bit more confusing to beginners. So I just leave them out. You might also be wondering why I'm writing semicolons before, at the end of some of these lines, but not others. It is good practice in JavaScript to write semicolons at the end of lines, but sometimes I forget, and usually things don't break, so you'll probably be fine without it. If you want to do things absolutely perfectly, then write semicolons in. Don't stress too much if you forget it. I don't think anything should break in this sketch if you don't write semicolons. So if you didn't understand what any of that meant, then don't worry about it. It's not super important. But if we hit play now that we've defined our X coordinate and a Y coordinate, 10 of those each, and then our bar width and bar height are 100 pixels each, we can hit play and we get a beautiful rectangle up in the top left-hand corner. Isn't that lovely? So this is, I guess, like, this is something to keep in mind when working with P5, which is that you notice I said pixels from the top edge, and or like when you're drawing with computers, you're almost always measuring distance, like y coordinate distances from the top of the canvas. And that, you have to remember, is the opposite way around to the way we normally do things with charts, like bar charts and things, where greater numbers go upward, right? Here, greater numbers go downward. So if I made this 50, say, then we would get it further downwards, not further upwards. So remember that, as well as the whole starting counting from 0 thing. If we wanted to move this rectangle to the bottom left edge, then we could type something like, you remember we said that height is the height of the canvas? So maybe we could type something like height here, minus 10, because we want to be 10 pixels off the bottom edge. And this doesn't work either, because the other thing that you need to know about P5 is that shapes have anchor points, and the anchor point for that shape, for squares and for rectangles, is in the top left-hand corner by default. You can change this, but that's more of an advanced topic, and I'm not going to be talking about that today. For our purposes, we're going to use anchor points in the top left-hand corner. So what we need to also do is move our X and Y after our width and height, so that we can then use our height as one of the variables in this, right? We can say it's the height of the canvas minus 10 minus the height of the rectangle, bar height. And if we run that, then that works perfectly. And what we could do here even is we could change the height of our canvas. If we made it suddenly 500 pixels tall and hit play, sorry, I made it 500 pixels wide. Let's make it 300 tall, let's say. Then it would still be 10 pixels off the edge, because we've used this height variable and it knows that this is 300 now, not 250. But for our purposes, let's bring it back to 250 and gaze upon our beautiful square here. Okay, so we've got a bunch of variables that we've made here now. We've got a width of the bar, we've got a height of the bar, an X and a Y, and we're starting to look at some of these things here. So the next thing that we want to do is figure out the width and the height, okay, because they're not going to be 100. So let's move this up here, this comment, and make some space below it. And let's think about what we want, what we want our width and our height to be. Okay, height is pretty straightforward, right? Remember, it goes from the bottom of the canvas to the top of the canvas. So we know that we've got that stored in a variable called height. So we can say the bar height is the height of the canvas, all right? The width is a little bit more complicated, right? We've got a bunch of years, and we want to have each one sitting right next to the other one. So we want to do something like the width of the canvas divided by however many data points there are. But how do we know how many data points there are without manually counting them up? We already use this table get function to get a single value out of our table, but we can actually use another method for tables here to get out the number of rows. And we can look it up in the reference. If we go to table and we go to this P5 table constructor and we scroll down and we can look, and these are all the different things you can do with the table. You can remove rows, you can find rows, match rows. Hold on. Oh, this looks good. Get row count returns the total number of rows in a table. That is exactly what we want. So we can say, let's make another variable and we'll call it bars, so that we track the number of bars that we have, which is the number of rows in the data set. And we just say, sorry, table dot get row count. Watch the capitalization there. And we can just put brackets here and a semicolon because we're being good. And in fact, let's just make sure that's working by console logging our bars. And if we run this, then we should see we get 140. And that sounds about right, doesn't it? Because our data started in 1880 and it goes to 2019. So yeah, 140 rows sounds about perfect. So what do we want the bar width to be? We want it to be the width of the canvas divided by this new bars variable. So we can say width divided by, which is a / in JavaScript, bars. And this should work nicely, right? We can see, yes, we have a nice thin bar that looks about the right size that we want for our thing, but it's in the wrong place, and we'll look at that in a moment, okay? So, it's gonna take a sip of water. Let's write that loop that we talked about before, because everything now the position of each bar and the color and drawing it, that needs to happen in a slightly different way for each bar that we have. So we're going to bring this comment up. And in fact, while we're at it, let's bring up, we've got some of the other ones here. Let's bring them all up and fit things in here. Drawing the bar, we've got some drawing the bar code, so that's done. We've also got figuring out the position of the bar. That's our X and Y coordinates, that goes there. We don't have any code yet to figure out the color, but we'll come to that. And we need to write this loop. And for this, we're going to use a tool from regular JavaScript called a for loop. And this is, it's going to look a bit complicated and scary if you've never done for loops before, but I'll explain how it works. I'll type it out slowly. We should be good, all right? So we're going to type for, not fro, for, I can't type today, and then a pair of brackets, and then we're going to do a set of curly brackets, and we're going to do enter here. And what it's going to do is it's going to loop over all of the things in the data set, and it's going to execute the code that's between these curly brackets. But we need some stuff inside these regular brackets here, you see? It's gone red underlined to tell us that something's wrong here. So what we need to do is we need to have 3 different things in here separated by semicolons, okay? First, we're going to say let I equals 0, then a semicolon, and then we're going to say I is less than bars, and then another semicolon, and then I plus plus, okay? Make sure that you've copied that down exactly right, because this will work, it won't work if you get it wrong in some way. And while you're doing that, I'll explain what all of these parts are, okay? So here, this first one, let I equals 0, this is initializing a variable that is that we're going to use to track our progress through the loop, okay? It's going to start at 0, and then we say that we want to run this loop while I is less than bars, which we saw before is 140. So while I is less than 140, it's going to keep looping, okay? And then lastly, we say every time it loops, we want I to increase by 1. We could also write this like I equals I plus 1, or we could say I plus equals 1, or I plus plus, which is the shortest. This is JavaScript. There's a million ways to do everything. I plus plus is the shortest way of saying every time you run the loop, make I go up by 1. So what this loop is going to do is we're going to start at 0, and then we are going to go to I is 1, and then I is 2, and I is 3, and I is 4, all the way up to I is 139, because when it, like, while it is less than bars, it runs. When it reaches bars, when I is no longer less than bars, it's going to stop and it's not going to run anymore. And we're going to use this I in 2 places. The first is to figure out where things should go, and then the second is to actually get the data point at that bit in the data set. Okay, so we can now move all of this stuff here inside our for loop. Okay, and I'm going to just take a moment to fix the indentation so that we can see things. I'm going to collapse the files thing there and drag this out just so that we can get enough on one line, and you can actually see this indentation here. Indentation is, it may seem a bit faffy, but it's a really nice way to just like organize your code, make sure that you can see what is happening where inside things. In this case, the curly brackets for the for loop start before all of our bar stuff and they end after it. So make sure that the end curly bracket here, you can see which one it's attached to, because P5 very helpfully draws an outline around it, and the same with any other bracket. Yeah, you want to have all of your other code inside this, and there should be nothing else at the end apart from one more curly bracket here, which if we scroll up, we can see this is attached to our draw function. Okay, so you've got all of this code. You've got the for loop, you've got our X and Y coordinates, and you've got your rect, and then you have 2 more curly brackets. Okay. Now, let's think about the position of the bar. And again, the Y one, we don't want it to be height minus 10 minus bar height. Remember that we said that the distance is from the top edge. And in this case, we want our bars fixed to that top edge because they are the height of the canvas in size. So y can just be 0, all right? And then x is just a little bit more complicated. Right? If we look at the original, we've got this first year here. So it's on the very left edge of the canvas. So x would be 0. And then here it's bar width away, and then another bar width, and then another bar width. So 1 times bar width, 2 times bar width, 3 times bar width. And we've got this number already that goes up by 1 every time we go through the loop, right? And it's I. So we can say I times, which is an asterisk in JavaScript, bar width. All right? And then if we run this, we should get a beautiful set of bars going across the screen here. All right? That looks great. So all we need to do now, we're pretty much there now. All we need to do is make these the right color and we're going to be done. We'll take another short break here so that people can catch up. And if you're already caught up, then maybe have a play around with the X and the Y variables to think about how you might turn this into a bar chart, for example, if you change the bar height and made that relative to the data. I haven't told you how to get the data out. Well, I have told you how to get the data out with this table get function, but we haven't used it in the code down here yet. So you can play around with that if you want to. Again, if you've got I'll share my version of the sketch at this point and paste it into the chat. We have a question in the chat. Does get row count exclude the header row? Yes, it does. So you don't need to worry about that when it's counting up. Yeah, if you have if yours is working fine, you can help other people in the chat who have theirs not working, or compound and just, yeah, do whatever. But when we come back at, let's say 5 minutes past the hour, then we will start with this version, which you can get access to from the chat menu. All right. If you have any questions, drop them in the chat. Otherwise, I will see you then. Okay, I hope everyone's code is working out well. I had a little question about how we've got so many stripes when we only told it to get one value of the data, and to explain this, all I'm doing here is I'm getting one value and then I'm just throwing that out to the console here, minus 0.43. The reason we've got so many bars is because we are getting the row count from the table and we're storing it in this bars variable, and then our loop uses that number, which is 140, to figure out how many times it needs to run. So we haven't actually attached any data to these bars yet. We are just I guess we're just, what's the best way to describe this? We're just using the number of rows in the data set to say how many bars we want. And in this section, we're going to move this this get command down into the loop so that we can actually get each data point in turn. Okay. So yes, what we've done in the last session is we have learned to draw rectangles, and we've looped over our data set to draw one rectangle for the number of data points that we have. So all we need to do now is make them the right color, okay? It is nice and simple to change the fill color and the stroke color of a bar in P5. You just type fill or stroke, all right? And if you want one to have no fill color or no stroke color, you just add the word no in front of it and you cap up the second word. So we don't want a black stroke color on these rectangles, so I'm saying no stroke, but we do want a fill color, all right? And the way we do this is we type color using the American spelling of color, which again, I always get wrong. I'm gonna get rid of this U just to be sure there. And then in quote marks, we can put in just the name of a color. So if we wanted to make them all green, we could just do this. We say fill, color, green, no stroke. And if we run this, we get loads of gray rectangles. Green rectangles. Now, a couple of things about this. One is that depending on your machine, the machine that you're running this on, you might see little white lines between the bars. This is because the width of each bar is not a whole number. There are ways to round that to a whole number by doing, I think it's like math.round is the function that you would want to use, but I'm not going to bother to do that in this sketch because once they're all different colors, we're not actually going to be able to see these tiny little white lines between it, and it's a little bit confusing. So I'm going to leave these white lines here. If you struggle with that in the future, then you can round the width of, or the height of whatever it is of your shape, so that it is an exact pixel value, because right now it's trying to anti-alias between the two. There's these tiny gaps. Okay, so let's talk about this color function in here, because this is super magical. I love P5's color function. You can throw all kinds of mad stuff at it and it will just work, right? You could type in olive, and it will just come up with an olive color. And if you want it to look all D3, which is a visualization library for JavaScript, you could type in steel blue, which is the default color. And suddenly we have a Mike Bostock visualization right here. I apologize, Mike, if you're watching us at any point. To know the names of the things that you are putting in here, there is these are HTML colors, and if I can access the plus tab thing and we go to a list of them, here they all are. I'll put this link in the chat actually. There we go, so that you can access this and you can type in any of these words to get that the color that you want. So let's say we wanted chartreuse bars. We can copy that and we can just paste it in here, chartreuse, and then, wow, that's a little bit bright. I think let's go back to what would be a bit nicer. Maybe a powder blue. I do like powder blue. Oops, I doubled that up. Powder blue in the quote marks, and then, that's a little bit calmer, isn't it? You can also throw other things in quote marks here. So you could just put in a hex code. So like if we did, I don't know, I'm just going to make up a hex code here, AB19C4 or something. What color is that? Ooh, nice deep purple. color. You could also give it 3 numbers, not in quote marks this time. If we gave it, let's say, 100, 200, 150, for example, not a dot between those, a comma. These need to be separated by commas and not in quote marks. And if we run this, then we get, it's a nice light green there. This is red, green, and blue values. And they go again from 0 to 255. But again, if you write like 3 point whatever that is, it's still going to work. It's just going to clip it to the maximum, which is 255. You can also give it minus whatever, and it will clip it to 0 in the same way. All right. So these are very forgiving functions. If you go into the reference, you can learn all about how this color function works by typing in color. Again, remember the American spelling. And going to this, it's the second one down here, color method. And you can scroll down and you can get lots of examples. There's loads of them. There are various different ones you can do. You can do hue, saturation, brightness values, which I generally prefer to use rather than RGB. I find them nicer. You can also add alpha for transparency and all kinds of other stuff. You can go and investigate yourself. In this case, though, let's just keep them green for the time being so that we can adjust it later, because we know that green is never going to appear in our data. So if a green does appear, then we've got something wrong. And what else? The other thing I'm going to do here is I'm actually going to abstract out this color here, and I'm going to call it col. I'm going to say col is color green, right? And then I'm going to say fill col. And this will work exactly the same way. It's just that we have this on a different line, and we can play with this more easily. We can put some logic around it to make it go blue or red ourselves. All right. So we've got this filling it the color that we specify, and we're saying no stroke. All right. Now, how do we map our data to a color? Well, let's think for a moment about what we want our scale to look like. We talked about this a little bit before, right? We want it to go from the lowest data point maybe is blue, and the highest data point is like this dark red color, and it sort of scales in between through white, which should be around 0, okay? So we need to think about how that might work. And to do that, we need to, again, go back to our data and take a look at it to understand it. So we're using this first column here, not the 0th column, the first column. And let's look at what we've got. We've got lots of negative numbers here. How low does this go? We've got a minus 0.46, a minus 0.48. What else do we have here? We could use like min and max functions if this were more values, but I'm just going to skim over it in this. Here it goes through 0, and then we're going up because of climate change, and we're above 0 now. We've got 6.1. We've got a 5.4. Oh, it's going up even more. We've got a 1.01. So I think we can safely say that our data goes down to about -0.5, and it goes up to about 1 between its minimum and maximum extents. And because colors in P5 are quite forgiving, we don't need to be absolutely pixel, like shade exact on that. So let's kind of think about this. We definitely want the maximum red color to be a value of 1, but what about the bottom end? What do we want to do there? And this is where, like, you as a data visualization expert get to make a decision, right? You can map it to the minimum of the data set, which is -0.5, but then we'd be in a bit of a weird situation where the saturation of the color changes at a different rate. It'll change twice as fast above 0 as it does below 0. So we might want to set the minimum point to actually -1, so that -0.5 is the same saturation as +0.5. But this is data art, and you are the artist, so you get to decide what you want to do here. My main advice from experience is to just make sure that you can defend your decision and that it's documented somewhere. If it's on a subject like climate change, then you'll find lots of people looking for flaws in your work. So just be able to defend what you do and you'll be fine, okay? So going back to the code, right now everything is green, which is definitely not what we want, but it's a step towards it. What if we I don't know, this is going to be tricky. We know we want to scale the color from white to blue, and there's lots of points in between that, right? But let's forget the scaling for the moment and maybe start with the simplest possible version of what we're trying to accomplish here. This is a coding technique that I use all the time, right? If I want to do something complicated, I think, right, what is the simplest version of this that I could take to get a step closer to what I want to do? And I get that working, and then I just add more and more complexity slowly until I get where I originally wanted to be. Okay, so what might a simpler version of this look like? Well, what if we did below 0 is full blue and above 0 is full red, and not worry about the scaling at all for a moment? Let's try doing that. And we could do that with a conditional statement, an if statement, okay? And we're gonna put this inside the for loop. We're gonna use this color variable. So let's do it just above that. Let's say if, and then we have a test in here. If something, then we want, those should be curly brackets. We want to have our col is color and let's say red, and then we say else, and we have curly brackets again, our col is color blue, right? So then we say if whatever we're checking for is true, then our col, like the variable col, should be red, otherwise the variable col should be blue, yeah? And then we just need to figure out what this test is, and that's quite simple, except it isn't, because we've forgotten to do one thing here, and that's actually get a data point. Now, we have got a data point up here in the setup function where we're saying table get 5.2, but we want to get the data point for each row in turn as we're going through the loop. So I'm going to cut this out here, and I'm going to bring it down, and I'm going to put it above our if statement, okay? And we don't want to console log it anymore, so we can get rid of that. We want to store it in some kind of a variable though. So I'm just going to call it D for data, right? And so we say table get 5.2, but if we did this, it would always be the 5th row and always the 2nd column. And that's definitely not what we want, right? We want the, going back to the data, we want 0, 1, column number 1. So we can put in a 1 here instead, because this was the, if you remember, go all the way to the top. We've got the global value, global. And what is our row number going to be? We want it to be the 0th row, then the 1st row, then the 2nd row, then the 3rd row. And you probably already know what we're going to put in here. We're going to use this I variable that we made before that increases every time it runs through the loop. So we can say D is I1, which is row I, whatever I is at that point in the sketch, and then column 1. Okay, and our test, we want to test to see if D is, what is it? If it's true, it should go red. So we want to say, is D greater than 0? If that's true, col should be red. If it's not true, else, col should be blue. Okay, and put some semicolons on this, like good coders. And we can run this and see if this works. I'm going to zoom in slightly, because I zoomed out before. There we go. We can run this and see if it works. Yes, we have some data art. And again, you can already see climate change in this, right? You can see colder than average years, warmer than average years, and then this bit in the middle, this reference period where it kind of moves up and down around the 0 point. Okay, so this is looking pretty good. We just need to worry about that pesky scaling, okay? For that, I'm going to introduce you to a really exciting function, one of my favorite functions. It's called Lerp Color. So let's look it up in the reference. L-E-R-P color, okay? Lerp is short for linear interpolation. And that's exactly what we want to do here, right? We want to linearly interpolate between two colors. You can do it with numbers with just the lerp method, but we're going to do it with colors, Lerp Color. And we can look this up. This looks good, doesn't it? Blends two colors to find a third color somewhere in between them. Perfect. That's exactly what we want to do, right? And it has 3 parameters. The first one is the first color. So it interpolates from one color. And then C2 is the second color. So we go to that color. And then the amped, which is amount, is a number between 0 and 1. And that's how far we want to be from the first color to the second color. And this is really handy because this number goes from 0 to 1. And as we just found, handily, our data goes from 0 to 1 as well, or minus 1 to 1, let's say. But we'll worry about that in a minute. So if we go back to our, let's nab this syntax and copy it and go back into our web editor. And instead of just saying color red here, we're going to throw in this Lerp Color thing. And for our color 1, we're going to say color white. And for our color 2, we want color red. Make sure you get the brackets right here. I didn't. Color white, comma, color red. I'm going to move this out so that you can see the whole thing in one go. Lerp color, color white, color red, and then amped. But we don't want amped. We just want D here, right? D is our amount. We don't need to change the scaling on that or anything. We know that if it's above 0, it goes from 0 to 1, right? But what do we do below 0? This is just a little bit more complicated. So we're going to copy this and we're going to paste it down here. We're going to go from white, but not to red this time. We're going to go to blue. And then how would we flip this? So instead of going from 0 to 1, it goes from 0 to minus 1. Well, what we can do instead is just flip what we put in. If we say minus D, a minus of a minus makes a plus, as you probably remember from your high school maths. So yeah, this should now, if we take the negative of D, and we know that D is always a negative number here because it only happens when the 0, or it's exact, like D is exactly 0. Then we have negative of a negative number, which becomes a positive number, and that scales all the way up to 1. So that's perfect, right? We can put those in, we can hit play, and we can see if this is going to work. You ready? Drum roll. Have I got anything wrong? Nice. We have climate stripes. We have warming stripes here. This is looking good. It's not exactly the same colors that we had here, but that's fine. We could play around with our colors later. We could put in hex codes and do all kinds of fancy things here. What it's doing very nicely is it's going through, it's going for like the dark blue for the coldest years, and we've got a dark red for the warmest years, and it passes through white in between, which is exactly what we were trying to do. So I think we're kind of done here, right? We can save this out if we want to with a right click and then save image as, and that'll store it as a PNG in wherever you want it to go. You could, if you wanted to change the size of your sketch so you can get it out much larger, you could change the number, and this should automatically adjust. Like again, if we made this 300 pixels tall and we run it, then it looks just fine because we've used our height and our width variables in our calculations that we did to figure out what's going on here. Okay, so that is the end of the live coding part of this workshop. Let's quickly recap what we did so that you can follow along and just sort of get an overview of everything. So the first thing we did is we preloaded our data by using the load table function to access data.csv, and then we stored all that information into a variable called table function. We created a canvas of 400 by, I'm going to go back to 250 pixels, and we stopped the draw loop from looping, okay? And then in our draw function, we made a background color, which actually we probably don't really need at this point because, yeah, we've got bars being drawn over the top of it. And then we figured out the height and the width of each bar by querying the table, getting the row count, and storing that in a variable called bars. We don't need to console log it anymore, so let's get rid of that. And then defining our bar width and bar height, which are the same for every single one of the bars. Then we looped over the data set, and for each data point in turn, we figured out the position where that bar should be using our bar width variable. And we got the data point, and then we said, if that data point is greater than 0, I want you to scale from white to red with the like the data point that we have. And if you want it to, if it's below 0, then we should scale from white to blue with the negative of the data point, which is always going to be negative, so it becomes positive. And then we set that as our fill color. And we say we don't want a stroke around our bars because that looks ugly. And then we just draw the bars with this rectangle function, which takes an x coordinate, a y coordinate, a width variable, and a height variable. And that's it. Like, it's that simple. That isn't a lot of code. What have we got? We've got a lot of empty rows at the bottom here that we could, whoops, not delete our last semicolon here. We've got about 40 rows. And if we, took out some of the spacing that we've got and the comments and things like that, it would probably be like 30 rows. It's not a lot of code to make a piece of data art that has, traveled around the world so many times. It's been projected behind bands playing at festivals. It is an incredibly influential piece of data art, and you can do it in just 30 lines of code. So I hope that gives you some confidence that you could do something similar, perhaps, and some excitement. What we'll do is I'll share this code. This is the final version of the visualization now. So I'm going to share this code and put it into the chat so that you can access it yourself and you can come back later and play with it. We'll take one more break here to give people a chance to catch up with the code. If yours isn't working, then again, check for missing brackets, check for spelling mistakes. If you're getting errors in the console, like let's intentionally misspell color here and break it and run it. And it just sort of gets halfway and then stops. But it says, P5 says, it seems that you may have accidentally written color instead of color. How nice is that? Most coding languages do not give nicely written error messages like this, especially not ones with a lovely flower next to them. And then we're like, yeah, it even tells us which line, right? Line 29, line 29, we can just fix it. So P5 is just, it's really lovely to debug with compared with other languages. And we run that again and then it works nicely. Okay, if you're caught up, then maybe have a go at visualizing other parts of our data set. You could visualize how the Arctic has changed, perhaps. And to do that, because I happen to know that the Arctic is warming much, much faster than the rest of the world, you might need to look into a function called map, which lets you scale a value, remaps a number from one range to another. Remember that our Lerp Color needs a number that goes from 0 to 1. So if it starts going above 1, then it's going to start looking a bit weird. You'll need to use map to fix that. And that'll be a really important tool in your data art toolbox, I guess. So yeah, you could also try different colors, right? What would it look like if it went from green to pink, or it passed through black in the middle, or both of those things? Have a play around, see how it's going. If you want to, if you're having difficulty with your code, then you can put some questions in the chat and people will try and help you with that. Otherwise, we will come back at, let's say, 33 minutes past the hour in 5 minutes time. And yeah, we'll be able to go on from there. I'll leave this bit here up on the screen in case you want to, yeah, in case you're having trouble getting it to work and you want to compare your code with mine. I'll move it along so that these are all nicely on one line. All right, go get yourself a tea, go to the loo, and we'll see you back in 5 minutes time. Okay, I think we are about ready to start again. I hope you're all feeling suitably relaxed and proud of yourselves and that you managed to get things working, or even if you didn't, that you were able to load mine and get that version working and maybe play around with it a little bit. You can relax now. There's not going to be any more coding in this, and just enjoy the rest of the presentation. I can skip through these break time slides. And yeah, let's talk about what else we can do with P5. So I would highly recommend, first, I'll just say that it might be fun for you to get some climate data for your own area and adjust the color scheme or adjust the size of the bars or something like that. Play around with it as much as you can, because I find that playing around with a piece of code that's working is easier in some ways than trying to create something yourself from scratch, but it will still give you lots of really, really useful knowledge about how a piece of code works, like just poking it and breaking it intentionally and then undoing it and seeing what changes and all of that. So definitely get your hands dirty in the code there. But there are loads and loads of functions that we didn't have time to cover today. And so I'm going to go through them, and I'm going to go through this quite fast because the time is passing. But I want you to get a little sense of what's possible with P5, because that's always the challenge I find with learning a new library, that you don't necessarily know what you can do. So we did rects today for our bars, but you can also do squares. You can do ellipses and circles. And one thing to note with ellipses and circles is that the anchor point where you present the coordinates for, with rect and square, it's in the top left corner, but with ellipses and circles, it's right in the center. So it's a bit easier to position those. You can draw triangles and you can draw quads if you wanted to. You can also draw points and lines and arcs, and I apologize for my slightly badly drawn arc here, but that's what you get when you try and draw nice curves in Google Slides. You can even make custom shapes by passing the begin shape function and giving it vertexes and then writing end shape. And that lets you create kind of lines, and you could do fancy line charts and things with that if you wanted to. One thing that I really, really love, and as soon as I understood how to use it, I was like, oh my God, this is amazing, was to use the push and the pop functions. This is kind of like almost like a save point for the styles that you are plotting with, you are drawing with. If you write push and then you give it new fill and stroke details or any other kind of visual style parameters, then it will change to those parameters. But then when you call the pop function, it'll go right back to where you were before. And you can even nest these in complex ways. So it's a really nice way to temporarily add style to just part of your graphic while leaving a kind of default style for the rest of it. You can also use P5's powerful DOM library to add other things to the page, like sliders. Could be connected to variables, and then you animate them, and then it moves in response to whatever you're doing. You could also, there's also loads and loads of array functions, which when you're working with data is hugely useful. There's like sort functions, there's shuffle functions, there's reverse functions. You can also interact with the user, reading their mouse position and their key presses. You could make a game, for example. You could interact with the user by getting the acceleration or rotation of their mobile device. And this is really cool. I'd love to see more data art playing around with mobile devices, because almost all data art tends to be made at the desktop. And I think that's a real missed opportunity, especially in terms of reaching a greater audience around the world, where far more people are on the internet with their phones than are with their computers. As well as loading CSV data, which we did today, you could load text or JSON data or XML data. There's lots and lots of maths and trigonometric functions, so you don't actually have to remember how to do Pythagoras if you want to figure out the distance between 2 points. And in fact, if you are trying to figure out the distance between 2 points, I really recommend getting familiar and playing around with the P5 vector class, which lets you define a point and define another point, and then play with all the interesting relationships you have between those things. Vector maths can be difficult, especially if you're working in 3 dimensions, and the P5 vector class makes it super simple. So they've done all the hard work so that you don't have to. There's lots and lots of randomness and noise functions if you want to do more generative work in P5. Noise, if you're not familiar with it, is a special kind of randomness that how do I describe this? I guess it sort of varies smoothly across a number space. So each number is similar to the numbers that are to the left and right of it, but they are still random. And you can create noise in 1 or 2 or 3 dimensions. It's really nice for creating organic looking textures, coastlines or mountains, the rolling hills, that kind of thing. There are lots of helper functions to work with time, which again can be a real pain in code. And there's also even, like, I've never played with this myself, but you can do crazy stuff with lighting and camera angles and even like assigning materials to your objects and shapes and things. There's all kinds of crazy stuff that you can do with it. And one of the nice things is that you don't actually have to remember all of this stuff yourself. As well as being in the documents, there is a really nice cheat sheet available. I'm going to link this in the chat. Copy and paste. And yeah, this lets you get basically all of the basic P5 functions that you need right at your fingertips. You can print this out, stick it on your wall. And then it's also available in several languages. It was created by a guy called Ben Moram, and it's also distributed under a Creative Commons license, so you can remix it for your own purposes and then republish your own version. There's lots of kind of free licensing stuff around this. So this is a really useful tool to have. There are also extensions to the P5, like basic stuff, which is things that other people have developed and built for P5. This is one called P5 Sound, which lets you access web audio. So you can do like audio input, playback, manipulation effects, like loads of crazy stuff. Build your own synthesizer, start sonifying data if if that's something that you want to explore. And that's something that I'm really interested in. So if you're interested in sonification, then definitely send me a message. I've never actually tried it with the P5 Sound library. I use another coding language called Sonic Pi for that, but I definitely should. It's on my very long list of things to do. But in short, there's loads and loads that you can play around with P5. You're not going to get bored fast, and you can do it all in the p5.js web editor without installing a thing. That's my favorite thing about P5. You just open up the page and boom, start coding. There's no like starting up servers and running Anaconda or whatever. It's just open a page, start coding. It's really, really nice. And then the one thing that you cannot do easily in P5 is create vector-based artwork. And this is a real pain, and I have had this pain myself. There is an extension called p5.svg. I'm going to link to it in the chat. I've not had great results with it myself, but I haven't played around with it heaps and heaps. Here is a link. If you Google P5 SVG, you might find some tips and advice on how to use this. But P5 works with the HTML5 canvas, and so everything is canvas-based and raster. If you do want to work with SVG, the path that I took for making my own SVG art is to use a different library. I use Rune.js for most of my vector-based work. It is not quite as simple and easy to use as P5, so I wouldn't say jump straight to that, but it's something that you can definitely, it doesn't take ages to learn, and some of the basics are the same. It doesn't have a draw loop like P5 does. It has the thing called a scene graph where you move objects on and off the stage, and yeah. Go and read up about it if creating SVG art and vector-based art is something that you want to do. I know it quite well at this point, so I'm happy to help you troubleshoot if you reach out to me. You could also go straight into the deep end and start learning D3, which is more challenging. I mean, there's beginner level entry points for D3. I learned some D3 a couple of years ago knowing nothing about JavaScript, and I was able to get some stuff out of it. So yeah, if you want to make SVGs, D3 will let you make the SVGs of your dreams. It's very, very powerful, not quite so nice to work with as vanilla P5. And then finally, I just wanted to talk a little bit about inspiration and where I get inspiration from. I think that this might be a bit controversial, but I think that the very worst place to get inspiration from is the world of data visualization. And I say that for two reasons. One is because you don't want to make things that other people are making. You want to make something different. Otherwise, you wouldn't be trying to make data art. And then secondly, you don't want to make things that look like visualizations, right? Otherwise it wouldn't be art. It would just be more data viz. So I definitely recommend like not filling all of your feeds with data visualization that other people have been making, and instead look further afield. I really like to look at abstract art as a, I guess, like a starting point for some of the things that I want to make. This is just a Google search for abstract art. This isn't a list of my favorite abstract art pieces or anything. But you can pick a piece you like. Let's say we picked this one down here, this red Scandinavian abstract. And like you can break this down and you can look at this and you can think, right, where could I map data onto this? So there's some obvious stuff like, whether the shape is filled or whether it is just stroked, or the thickness of the stroke or the color of it. There's like 3 different colors here, the size, the position. There's all kinds of these factors that you can build in. Stuff random. Maybe the shape is completely random, but the color is maybe based on your data set, whatever data set it is you're using. I would say that as well as these kind of like obvious things like, the color or the size of a shape, have a think as well about some more nebulous parameters that you might want to explore. Maybe like the transparency or the waviness or the complexity of a shape or something like that. I like how these red triangles here look super angry. And so if you've got, I don't know, like some sentiment data, you could code it so that it's like bright red and thick if it's an angry looking if the people are angry, and a bit more chill and calm and small if it's not. I definitely recommend like pulling in multiple encodings on things like that. And yeah, if you want to make something that's understood without a legend, then definitely, like Ed Hawkins did, go back to these like common common principles of sort of visualization that are understood outside of the visualization world. Like the red is hot, blue is cold, or red is angry, or up being more and down being less. These things are built into everybody's brains, and so you may as well use them if you want to make a piece that is understood widely. You might also want to make a piece that's a bit more enigmatic and a bit more interesting. So you don't have to do that, right? You are the artist and you get to decide what you want your piece to look like. And then the other place that I really like looking for inspiration is in nature. Nature has all of the best patterns and nobody is going to sue you if you steal them. So that's a really great source of inspiration. I sometimes like to use data from the real world actually as a source of randomness in some of my generative art, which I guess makes it a kind of visualization, but it's very hidden. So like trees in a forest, for example, this almost looks like a circle packing arrangement because all the trees don't want to be right next to each other. They want to have space in between. Yeah. Or, like wind vectors on a map. Like this is really, really great for creating a flow field. And maybe you could drop a data point somewhere here and then see how it moves as time goes past or something. There's loads of interesting distributions that you can find in the randomness of weather data. And I know that the generative artist Tyler Hobbs, one thing that he likes to do is go out with his camera and look for textures that he thinks could be replicated in code. And he just makes generative art, but I think you can do this in data viz as well. And there's some great examples of this too. This is obviously a leaf pattern, but it kind of also looks a bit like a tree map, doesn't it? You have this large structure here, or even larger structure actually, and then you have a smaller structure, and you have a smaller structure, and you have a smaller structure. This is like hierarchical data right here, and you can make it look like a leaf, and it'll look beautiful. You could also do something with tree rings. There was a fantastic National Geographic piece a couple of years ago that used, get at my new tab. Here we go. Come on, T. I paste this in here. This is 200 years of US immigration data as the rings of a tree. And they're kind of presenting this as a visualization, but honestly, this is a beautiful piece of data art. I adore this. I think this is absolutely fantastic. So, this is a really good way to get inspiration from the natural world. What else did we have? We had tree rings. Oh yeah, blades of grass. I really like blades of grass as well. This if you sort of turn your head to one side, this could be a slope chart and maybe the thickness of each blade of grass or which one is in front of which one. You could map those to data. There's loads that you could do. You could find inspiration in flocking of birds. You could find inspiration in fluid dynamics, the complicated, incredibly complicated ways that fluids behave. And like many of these things are not easy. I'm definitely going to tell you that. Many of them are really hard, but if they're hard, then quite often either someone else will have done a lot of the hard work for you and you'll be able to access their code and see how they did it. And, you know, there'll be some sort of guidance on how to do it that you could adapt for your own work, or nobody has done it before, and in which case you're doing something that is completely unique and original. And it's a great way to stand out in the crowded field of data visualization by just adding more beauty to your work, by pulling inspiration from abstract art, from the natural world, from all kinds of other places that are important to you. So I think that's pretty much the end of the presentation. Here's a quick reminder of things about me. Here is my website again, my newsletter. I send it every 10 days. It's just about stuff that is interesting me and things that I've been working on. You can follow me on Twitter and on LinkedIn as well. You can find me there. You should definitely check out Loud Numbers, which we're going to be talking much more about next year. And I'm super excited about that. That's my sonification project. And also, this is the first time that I've actually run this workshop. So I would really appreciate any positive or negative feedback or just general comments that you have. You can shoot me a note in Slack or by email. I'm just duncan.geere@gmail.com. But otherwise, I think we hopefully have some time, 10 minutes or so for questions. But otherwise, thank you very much for joining me today.
It's hard to believe that was your first time you run this workshop, because it was...
I've been practicing it quite a bit, I gotta say.
It was really good.
Thank you.
I personally enjoyed it a lot, and I'm sure a lot of people have as well, because I'd say the dropout rate of this workshop is pretty much close to 0, which is very rare considering, you know, it's an afternoon workshop, it's a coding workshop. You manage to keep everyone locked in their exercises, and I think
I'm really glad to hear that. Thank you for everyone to being so patient with the coding.
I have one question, very quick, and then I'll open to anyone else's. When we were coding, I have almost 0 experience, but I did have a little bit of fun with processing back in the processing days, and there's a lot of similarities with is it almost the same language, just converted on a browser?
Yeah, yes and no. I mean, it's so the original processing runs in Java and not JavaScript, and despite the names, there isn't, like, they're similar in some ways, but they're very different in some other ways. There isn't an official connection between the two. I don't code in Java at all, but I have successfully managed to translate sketches that are written in processing into P5 to get them to work like between one and the other. So it's very possible to do it. I think if you look at processing code and you're familiar with P5, you'll be able to read it. You'll be able to kind of see what's going on. Like most coding languages aren't that different. Like, I'm sure those of you who have never done JavaScript before but know Python or R or something like that will really like recognize many of the similarities in here in the way that, you know, they all have the same tools, right? They've all got loops and variables and functions, and it's just the syntax that is slightly different. So if you can see the differences in syntax and figure out the bits that you need, especially with a simple example, then it should be possible to translate between the two fairly easily, I would say.
Cool, thank you. Right, let's see if anyone has any question. Let's starting with Morgan. What do you think? How did it go?
It was super great. Thanks a lot, Duncan. And yeah, as Peter mentioned, you have been a great educator, because this was literally I think the second time that I was coding. I know a little bit of HTML, but yeah, and I was able to follow you, so it was a big achievement for me today.
Oh, fantastic. Well, I hope you feel a little bit more confident in your coding skills, and you're going to now go away and try and do a few more things with P5. There's loads of great beginner resources for P5. There are loads and loads of great books. There's one called Generative Design that I particularly love. And there's also the Coding Train, Daniel Schiffman's YouTube channel. He uses processing and P5 as well a lot, and he's great to watch. He's been a very an inspiration for me, I would say, in my own personal learning journey here. So I definitely recommend those as resources. I can find those and throw them in the chat.
Yeah, that would be great. I think also for everyone else here.
We've got a couple of questions in the chat. A question from Isabella and Ellen. You referenced the limitation of P5 with SVG. Is there any other important limitation with P5 that we should be aware of?
Other important limitations from P5. I mean, I think that's the big one, really, that it does raster artwork and not vector artwork. I mean, any coding language that simplifies things for new users will always make it slightly more difficult for advanced users who want to accomplish something a little bit more complicated. But in those situations, the really nice thing about working with P5 is that if you want to do something slightly more complicated, you can just write regular JavaScript in that particular line and assign it to a variable or something, and it should work fine. So if a particular function in P5 doesn't work the way you want it to, then you can just write it as just like vanilla JavaScript, or even pull in another library entirely. If you want to use D3's code and then manipulate some of it or draw on top of it with P5, then yeah, you can mix and match, but be a little bit careful, because it can get a little bit confusing when you're working with multiple libraries. You're like, right, I'm using this one from this one and that one from that one. How do these two relate? So just be a little bit careful. If in doubt, use console log a lot. Find out what is actually happening in the inside of your code, and hopefully you'll be able to troubleshoot from there. This is the book. I'm just putting the book in the channel. And then Daniel Schiffman, the Coding Train, is here. Daniel Schiffman is a wonderful human being. I love him to bits.
Yes, and his videos are hilarious and super informative.
Yeah. So look, here he is down here, programming with p5.js, p5.js web editor, shapes and drawing. A lot of this is what we covered today. And then he has all these fun coding challenges, like making a double pendulum and a star field and Flappy Bird, the game, and everything. So yeah, it's a really great watch.
So one more question comes to mind. What do most users of P5 use it for? Is it to embed those results on other websites or platforms? I guess that's the main...
Yeah, I mean, you absolutely can do that with the web editor. If you go to share, there is an embed thing that will give you an iframe that you can just dump into your blog or almost any content management platform on the internet, I think. Not social networks like Facebook or Twitter, but in those cases, you can just link it to the present version or the full screen version, or if you want to share your code with your audience, you can just share the edit version and let them play around with it. I like to do that. Yeah, you can just embed things generally though, or just save out an image like we talked about before. Does that answer the question? I think I just talked about how to share it. Yeah, okay, great. Oh yeah, I was going to say, if you want to see some of the other things that people have done, if you go to p5js.org, they have just published a, where is it? The new P5JS 2020 showcase. So if you go here, there's zillions of different projects. Yeah, view the projects. It's here's a lion mask, and here is a game of plastic sweeper, and here is making fractals, and there's just so much stuff in here. And all of these, almost all of these, will give you the code. So if you just hit code here, you can see people's code. In this case, it is in the public folder, I think. No, it is not. It will be somewhere. Backend source code, maybe that's it there. Anyway, you can comb around GitHub as much as you want to, but there's loads and loads of great examples of yeah, fantastic things that people have built P5. Look, here's a game about living long and prospering as a bird. I want to play that now. I'm going to do that after this.
Maybe one last question from Ellen. Have you heard of any gotchas limitation if you try to use P5 in some sort of framework like React, Angular, Vue?
So my caveat to my answer on this question is that I am not a pro coder. And I haven't actually used a whole lot of other frameworks widely. I've never used Vue, React, or Angular. So this is an uninformed answer. But my uninformed answer is that I have not heard of any gotchas or limitations. I think if you are using one of those frameworks, you probably know the answer better than me already, I would say. Your Google is as good as mine.